Yes, hello there, Himanshu this side, and I am a physics faculty here at askIITians. So before you have come for this lecture, I hope you have attended the lecture number 1 of basic maths. And now what we have done in the lecture number 1, let me just recall. So you have got an idea about vectors. Why do we need them in physics? What is their purpose? For example, if I talk about the force, then you got to know that if I give you a force, the two forces, suppose, just a second. So suppose let's say we have a box, and on that box one force is acting in this direction 3 Newton, one force is acting in this direction 4 Newton. Then the total force won't be 7 Newton. That's what you have learnt in the previous lecture. Okay. Now if it is not 7 Newton, then what would be the right answer? Exactly. So how to add two vector quantities? That's what I am going to discuss in this particular session. So in this session, first of all, I'll talk about the addition of vectors. So there are two rules which we are going to discuss in this class. Second is the one more important mathematics which we will need, that is a differentiation. So what is differentiation? Why do we need it? Again, that also I will discuss with you. Why we are doing this? So that we can learn the further chapters like motion in one dimension, motion in two dimension, Newton's laws of motion, because Newton has also learned this mathematics, has come up with this mathematics to understand the other things which you are going to also discuss in the grade 9. All right. So let us begin our session now with the addition of vectors. All right. So let us start the class. So before we begin, there are some points, some miscellaneous points which we can discuss about the vectors. So first of all, a scalar quantity and vector quantity can never be added together. Suppose mass is a scalar quantity, 5 kg. Now you cannot add with the force. In the last class, you learnt that force is represented by I cap, J cap, K cap, like that. So force would be like a 2 I cap plus 3 J cap, something like this. Now you cannot do this. It is wrong, right? This is wrong. Simply, I can say that two physical quantities which are having different dimensions, different units, cannot be added together. That is also true. So by that same logic here also we are saying that scalar and vector can never be added together, simply like this. For any two scalars to be added, they must be of the same nature. Example, mass should be added with mass only, not with the time. Obviously, we know this. Like you cannot say that 5 kg plus 10 minutes. This does not make any sense. Yeah, we are pretty clear. It's very obvious. For any two vectors to be added, they must be of the same nature. Yes, force can be added with force only. Velocity can be added with a velocity only. You cannot do this, force with velocity. This is wrong. Right? These are very obvious things. Two physical quantities of same nature can be added together. Otherwise, you cannot do that. Very simple thing. Now, going ahead with the addition of vectors. So let us begin now with the first law. I am going to teach you today two laws which are related to the vector addition. Okay. So first is the triangle law of vector addition. Now, what does it says? Let us try to understand this law. So this says, suppose you have two vectors. So you can consider this pink color vector. This is a vector A. And you look at the arrow also. It is going towards right. Now you look at the vector B. This is the vector B. Okay. If you want to add these two vectors, A and B, you are going to get an addition of these two vectors. What do we call this addition of vector? This is represented by the symbol R vector usually, and it is called resultant of two vectors. It is called the resultant of two vectors, or simply you can say the addition of two vectors final sum. All right. So now here we can say that when you add two vectors A and B, the addition would be the final vector R vector. Now what will be the value of this R vector? Magnitude of this R vector. You should always try to relate it. What was our basic question? We have to learn how to add 3 Newton and 4 Newton force. This is important. This is the question we have to answer. So that's what I am going to teach you now here. how to add 3 Newton and 4 Newton force together. It won't be 7 Newton. It's not a scalar addition. So now that what does this triangle law of vector addition says? So this law says that when two vectors represented as two sides of a triangle, yes, you can see this A and B are represented as two sides of triangle. Notice one thing. Head of this vector is joined with the tail of another vector. You should notice this. Head of the A vector is joined with the tail of B vector. You have to keep it like that. Otherwise, triangle law won't be valid. So head of one vector is joined or is connected with the tail of another vector. Now the third side of triangle, this R vector you can see here. This third side of the triangle will represent the addition of two vectors, the resultant of two vectors. Got my point? All right. So simply, these two are the vectors. Now you complete a triangle here. This would represent the addition of these two vectors. 3, whatever is the direction, plus 4, whatever is the direction. Addition of these two would be the resultant vector. So that is what the meaning of triangle law of vector addition. Okay, we have got the statement, right? Third side of the triangle represents the magnitude and the direction of the resultant vector. Okay. Another thing. Now, what will be the value of the R? So for that, I am going to do some mathematical calculations here. All right. So before I begin with the mathematical calculations, some math knowledge would be required from your side. So let me just recall it, what mathematics we'll need. The mathematics is related to the right angle triangle. Okay. So let me just put a note over here. What maths I'm going to use to derive the value of R. So guys, what I'm going to do now, I'm going to derive the value of R. What is the value of R? ये तो हमने पढ़ लिया कि what is 3 Newton, what is 4 Newton, that's a force. Now when you add them, what is the final answer? That's what we have to answer now. So let us make a note first of all. In a right angle triangle, it's a right angle triangle. Okay. First of all, there is something called the Pythagoras theorem. If you have heard of it in the lower grades, you might be knowing about it, the Pythagoras theorem. Right. So what does this Pythagoras theorem says? Suppose this is A length. This length is A. And this length is B. So, and this angle is theta. This angle is theta. I'm representing it by some symbol theta. You can use some other symbol also, alpha, beta, whatever you want. So now, this is called the opposite to the angle. It's called the perpendicular. This is called the perpendicular. Perpendicular. This is 90-degree angle. The side which is opposite to 90 degrees is called hypotenuse. And the next, the remaining one is called the base. Now, so what does this Pythagoras theorem says? Hypotenuse square. Let me represent it by some symbol C is equal to perpendicular square plus base square. I will use this in the derivation for the value of R, for the magnitude of R. Okay. Or we can say C square equal to A square plus B square. Now, if you have heard of the trigonometric relations, sine theta, cos theta, tan theta, that also we can write here in the right angle triangle. So sine theta is the trigonometric ratio of two sides. Similarly, cos theta is the ratio of two sides. Then tan theta is a ratio of two sides. So first of all, sine theta, perpendicular upon hypotenuse. Perpendicular is B, hypotenuse is C. Perpendicular upon hypotenuse. Cos theta, it is base upon hypotenuse. Now base is A, hypotenuse is C. Tan theta, it's perpendicular upon base. So perpendicular is B and base is A. So don't worry, I'm not going to use them too much. Very small use I'll be needing here. So first of all, I'll use sine theta, I'll use cos theta, and the hypotenuse theorem, this Pythagoras theorem. These two things we are going to use here. All right. So let us begin now. So as I said before, we have two vectors. Let me draw the diagram. This is the A vector. So its length will be A, right? I explained this in the last class, that A vector means the vector along with its direction. But when you write down its magnitude, that you can simply represent with the symbol A. Then we have another vector here, B vector. All right. That's another vector is B vector. Got my point? Now here I have to do the addition of these two vectors. So what we know is the third side of the triangle. The third side of the triangle. This is the B vector. So its length will be B only. Okay. Now the third side of the triangle. So let us denote the third side of the triangle here. So that's the third side of the triangle. This is the R vector. We have to find out the length of the R vector. That's our target now. That is what we call the addition of two vectors. Okay. So suppose we come up here for the addition. So if you remember, in the last session, I have explained you how to find out the angle between two vectors. Do you remember that? So in your notebook, try to show the angle between two vectors. Can I say this is the angle between two vectors? Answer is no. That would be completely wrong. This is not the angle between two vectors. As I said before, in the previous session also, to show the angle between two vectors, you are supposed to join them tail to tail, right? Okay. So I will just extend this A vector a little bit. So somewhere here, the tail would be coming. And now this would be the angle between the vectors. All right. Suppose this is the vector A, this is the vector B. Now, if you want to find out the angle between vectors, then you have to join them from tail to tail. That's a rule. They should not be joined head to tail to get the angle between the vectors. Always remember this. Now, the next part. The next part is we have to find out the value of R. So now follow me. What steps I am going to use here? First of all, I have extended this line A little bit. So up till here, what is the length, guys? This is, let's say, point P. This is, let's say, point Q. This is, let's say, point T. Okay. Up till here, the value of PQ. The value of PQ is what? This value PQ. This PQ is what? A. That's the length of the vector A. Okay. That's the length of the vector A. What is QT? This is T. So what is QT? QT is equal to B. Okay. What is PT? PT is equal to R, length of those vectors. And our interest is to find out the value of R. Now you guys can see this is not a right angle triangle, but I can make it a right angle triangle somehow. So now you see what trick I will use to make a right angle triangle. This length, this red color vector, this A vector, you can see I'm extending this line little bit. So this will come here, and now you drop a perpendicular from here. You drop a perpendicular from there. After extending one of the vector, you drop a perpendicular from the point T. And let's say this point is O. Now anybody can see that the triangle POT is a right angle triangle. Yeah, that's a right angle triangle. If that's a right angle triangle, then I can simply say that PT square is equal to PO square plus OT square. One more thing, PT square is what? It's R only. See here, PT square is R only. So R square is equal to, what is PO square? Can I write PO as the addition of this plus this red color length plus QO? So I can write PO as PO. I'm talking about PO. I can write as PQ plus QO. So what is PQ? It is A. What is QO? We don't know. So let us just write it as QO. I have replaced PO. So this will become a square of it. What is OT? OT, I can say it is OT square. I cannot write it in terms of some other known parameters. That's it. Okay. But we have to find out the value of QO and we have to find out the value of OT somehow. So now, as I said before, I'm going to use these trigonometric relations, these things. So let us utilize them now. Remember this equation? Let me recall this as equation number 1, so that we can remember it later on, that we are referring to the equation number 1. Okay, let's come back here. QO. So now you look at the triangle. Look at the triangle QOT. That's again a right angle triangle. Look at the diagram QOT. So when you look at the diagram QOT, you will find what? Let us try to use the sine theta there. Sine theta. Can you write down the sine theta value? It's perpendicular upon hypotenuse, B upon C. So what is perpendicular here in this triangle? Perpendicular is the side which is opposite to the angle. That is OT. What is hypotenuse? So hypotenuse is this QT, and which is nothing but B only. QT is nothing but B only. So perpendicular upon hypotenuse. So from here, what you will be getting? Very simple. OT is equal to what? OT is equal to B sine theta. OT is equal to B sine theta. Similarly, let us talk about cos theta. Let us talk about cos theta. Now, what is cos theta here, guys? Cos theta is base upon hypotenuse. Follow this. Base upon hypotenuse. Now, base is QO. Hypotenuse is B. So from here, you will be getting QO is equal to B cos theta. Very simple. QO is equal to B cos theta. I am going to use these two things in the equation number 1. So QO I am going to replace with B cos theta. OT I am going to replace with V sin theta. Okay. So let us go to the next slide now. R square equal to, it was A plus, I'm using the equation 1. So QO is equal to B cos theta. B cos theta whole square plus OT was equal to B sin theta. So this will become B sin theta whole square. Now we just have to open it. How do we open A plus B whole square? A square plus B square plus 2AB. So see here, A square plus second term square, which is B square cos square theta, plus 2 times of multiplication of these two terms. So AB cos theta, 2AB cos theta. Next is B sin theta whole square. So that I'm keeping as it is, B square sin square theta. Now you see A square plus B square. Okay. Notice one thing here. This is B square cos square theta. This is B square sin square theta. I can club them, and B square I can take common. So when I take B square common, what will become? This will become cos square theta plus sin square theta plus 2AB cos theta. I know it's very too much mathematical, but in the end, we have to remember the relation, the final formula, right? Because that would help us to add two vectors. So A square. Now, what is cos square theta plus sin square theta? You come here. What is cos square theta plus sin square theta? You can easily derive it. Cos square theta means A square by C square. sine square theta, b square by c square. Let me write here simply, though it's a identity also, it is 1 basically. Cos square theta is a square by c square. Sine square theta is b square by c square. It's a square. When you take LCM, you will be getting c square, and in the numerator you will be getting a square plus b square. But what is a square plus b square, guys? It is c square. So pause here, try to see this once again. Right? If you have not understood this, it's an identity that cos square theta, which is a square by c square, sine square theta, which is b square by c square, addition of these two would be c square by c square, which is 1 again. So basically cos square theta plus sine square theta is always 1. It's always 1. So I'm going to simply write it as b square plus 2ab cos theta. So from here we'll get r is equal to, I'm going to put the square root. We will not put plus minus because the magnitude is always a positive quantity. It can't be negative. It's always a length. So that's the final relation we have got. Square root of a square plus b square plus 2ab cos theta. You have to remember this. It's very important in your grade 11th also. Okay. Many times you would be using this formula, right? Okay. Now one more. Let's do one example. Let us learn how to use it. Now suppose somebody says this is the 3 Newton, this is the 4 Newton, angle between them is 90 degree. What is the addition of two vectors? Okay. So here what you have to do, yes, you need to remember the cos theta values. At least few values you should remember. Suppose let me give you some of the standard values which you should remember at the grade 9. Theta and cos theta. If theta is 0 degree, cos 0 degree is 1. If theta is 30 degree, cos 30 degree is half. If theta is 45 degree, cos 45 is 1 by root 2. Oh, sorry, my mistake. This is root 3 by 2, not half. Then 60 degree, then it is half. If cos 90 degree, then it is 0. So here the angle between them is 90 degrees. So what will be the r vector? Magnitude square root of 3 square plus 4 square plus 2 multiplied 3 multiplied 4. Cos theta is 90. Cos 90 is 0. If cos 90 is 0, then r will be equal to what? 3 squared plus 4 squared. Answer will be equal to 9 plus 16, 25, and which is equal to 5. That's it. One more example we can take. Suppose you have this as one vector 6 Newton. Suppose this vector is 8 Newton. All right. And now let's say some angle is given to us. This angle is given as 120 degree. 120 degree this angle is given. All right. So here we get the confusion that the angle between the vector is 120 degree. But no. Now you have seen the lecture. You should have the clear idea that this is not the angle between the vectors. This is the angle between the vectors. Because vectors should be joined tail to tail to get the angle between them. This we have discussed in the last lecture in very much detail. We have spent around 15 minutes over it. So now r is equal to square root of 6 square. A is 6, b is 8 square. 2 multiplied 6 multiplied 8. Cos not 120, cos 60 I am going to use. So now what we will do? We'll just put the numbers here. 36 plus 64, which is 100, plus 2 multiplied 6 multiplied 8. Cos 60 is half. 2 and 2 will get cancelled out. So this will become 8 6 48. All right. So square root of 100 plus 48, which is square root of 148. Whatever is the unit here, that would be coming. Here also, whatever is the unit, that would be coming. Suppose you are adding two forces, then Newton. Suppose you are adding displacement, then meter, like that. All right. So that is the addition of two vectors using the resultant method, the vector method. Okay. The triangle law of the vector addition. I hope you have got my point. So in the triangle law of vector addition, we have to use this Pythagoras theorem to derive it. In the end, guys, you should remember the formula. Yes, it is very good if you know the derivation. It's really helpful if you know the derivation. But if you are not comfortable with it, if you feel like vomiting with it, then don't worry. You can at least remember the formula. All right. Because once you remember the formula, then you can apply it in the questions. But always remember how we have, what are the parameters, what is A, what is B, what is theta, how to find out theta. That's things we should know. The vector should be joined tail to tail and like that. Okay. So going ahead with the second law of vector addition, it is called the parallelogram law of vector addition. In the triangle law, let me show you once again. In the triangle law, the vectors were joined head to tail, head to tail. But in the parallelogram law, the vectors would be joined tail to tail. The tail of vector P is joined with the tail of another vector B. Can you see that? The A vector and the B vector. Okay, let us read it. If two vectors are simultaneously acting at a point, so here at a point, these two vectors are starting from here, or you can say they are meeting that there, then it can be represented both in magnitude and direction by the adjacent sides from a point. Therefore, the resultant vector is completely represented both in direction and magnitude by the diagonal of the parallelogram. Let me make it easy for you. So what basically they are saying? Suppose you have a p vector here. Suppose you have a q vector here. Do one thing. Make a vector parallel to p vector. Yes, this will be parallel to p vector. Okay. Now you make another vector which is parallel to q vector. So let us make it again. Just a second. So this was the p vector. This side was parallel to p vector, and this side was parallel to q vector. You have got one parallelogram. I can show you here in the better diagram. This is the p vector, and this is the vector which is parallel to p vector. This is the q vector. This is the vector which is parallel to q vector. Okay. Now this and this are parallel. This and this are parallel. The two things opposite to each other. You have got a parallelogram. Now, if you see the diagonal of these two vectors, this parallelogram, which is starting from the meeting point of these two vectors, the p and q, the diagonal, this green color diagonal, this is the resultant of two vectors. So that would be the direction of the resultant of two vectors. So suppose if you have a box, one force is acting 10 Newton this way, another force is acting 20 Newton this way. So basically what you can say, where will be the resultant? Resultant would be this way. The net force, the total force would be in this direction, like this. Got my point? Okay. So that's the meaning of parallelogram law of vector addition. And we have derived the addition of two vectors formula also, right? Okay. Now we can say that we have learned two things: addition of two vectors, right, using the triangle law, and also we have learned the addition of two vectors using the parallelogram law. Okay. So after this two topics, you would be able to add any two vectors. Any two vectors. Suppose if somebody says that if one object is placed, okay, and on this object there was certain force acting in this direction, and there was a certain force acting in this direction, right? So now you can simply say that the addition of these two vectors f1 and f2, they are joined tail to tail only. Okay, so addition of these two vectors can be given by that bigger formula, okay, which you have learned just now. Okay, and the direction will be represented by the diagonal. Every time now it should be in your mind. Every time you don't need to draw the diagram again and again. Yes, in the initial stages you can do that always. Suppose you make a vector parallel to this. So we have make one vector parallel to this. Make another vector which is parallel to f2. So this is another vector f2 parallel to this. And now you have made a parallelogram, then the diagonal would represent the addition of two vectors or the total force. I hope you got my point. That's the meaning of addition of two vectors. Okay. Now I'm going ahead with the next part, which is the differentiation. So before I begin with differentiation, first of all, I would like to recall you few points about the slope of a straight line. What does it mean? Okay. So do not get confused with this diagram. Let us try to learn in a very simpler way. Okay. So let me make another diagram here for you. Okay. Then we'll come back to that diagram and those formulas which you would see, which you have been seeing on the last slide. Right. So straight line means, just a second. Yes. So here we can see this is x-axis, this is y-axis. I'm going to make two straight lines. One straight line going this way and another straight line going this way. All right. Perfect. Right. So here you see one thing. Let us take 2 points. One point I am going to pick here. Okay. We can take some random numbers just to understand the things. All right. Otherwise, if I take x1, x2, you might be getting confused with that. So this is, let's say, the coordinate 2. X value is 2. All right. And another coordinate, let me take here, 3. And let's say at x is equal to 2, the y value is 10. There are two straight lines, guys. One is blue, another one is red. I'm going to analyze these two straight lines. Okay. Slope and all we will understand, but first of all, let us see few other things. So at x is equal to 2, both the straight lines are having the y value as 10. Let us make a table here. For blue, at x is equal to 2, the value of y is 10. Okay. For red color straight line, at x is equal to 2, value of y is 10. Yes, they both are at the same point. You can see here x is equal to 2. This is going at x is equal to 10 only. It's visible clearly here. This is x is equal to 2. Okay. And here you can see this is going at 10 only. Okay. Now let's go ahead. Let us take one other point at some other place. Let me take at x is equal to 3 now. At x is equal to 3, what is the value for the red color straight line? This is the value. This is the value for red color straight line. Okay. So this value is, let's say, 15. I'm just taking some random number just to make you understand the things. Okay. So for red color line at x is equal to 3, y is equal to 15. Okay. Let us see for the blue color line. Okay. For blue color line, the y is at x is equal to 3 is somewhere here, which is, let's say, 25. So here for blue color line, y is equal to 25. Okay. I don't know whether you have used it in chemistry or not. There is one symbol called delta. The symbol called delta. Its name is delta. It represents the change in something. Suppose in the unit test 1, you got a score of 60%. Then in the unit test 2, you got a score of 90%. You're very happy after hearing about it, right? 60 to 90, that's a very good increment. So 60 to 90 you have got. So what is the change in your percentage? 90 minus 60, which is 30. So change in your marks, delta M. This delta represents the change in a quantity, right? So here, what is the change in X? 3 minus 2, 1. What is the change in Y? 15. 25 minus 10, 15. Here, the change in X, 1. The change in Y, 5. Now you see one thing here. For the blue color line, the change is 15 when X value changes by 1 unit. When X value changes by 1 unit, the Y value changes by 15 units. For red color line, the X value changes by 1, hence the Y value will be changing by 5 only. Means we can say that for change in X, the change in Y will be greater. We can say that the change in Y will be greater. For what? Will be greater for blue color line, for blue straight line, for blue straight line. Got my point? That for the change in X, the change in Y will be greater for a blue straight line. You can see for Y, this is the change. But for red, what is the change? Only this much. So which graph is more steeper? The blue color graph is more steeper. Okay. So that's what represents the steepness of a graph. That's what represents the slope of a graph. Here, if you make a straight line here, horizontal line, then you can see this angle is theta 1 and this angle would be theta 2. So theta 2 is greater than theta 1. The theta 2 is greater than theta 1 means it is going towards y-axis. The blue color line is more steep, right? And the red color line is less steep. It's almost inclined towards x-axis. Means when the straight line is inclined towards the x-axis, the change is becoming less. But when the straight line is inclined towards the y-axis, the change is more. Okay, so that's what represents the slope. The change in the value of y with respect to the change in value of x. I hope this point is clear to you, right? So few things we can recall here. First of all, when graph goes towards y-axis, it will become more steep. Hence, its angle will increase from the horizontal. If its angle increases from the horizontal, then the change in values of y will be happening at the faster rate as compared to the other one, which is having the less steepness. Okay, so now let us go back. That's what we call the slope. The change in value of y, the change in value of y with respect to change in value of x. So here you can see for this particular straight line, the y is changing from y1 to y2. So change in y is how much? Which is represented by delta y. y2 minus y1. With how much change in x? Delta x, which is x2 minus x1. So this is x2, this is x1. That is what the meaning of a slope of a straight line. All right. So suppose you have two inclined planes. You have to climb this one and you have to climb this one. Okay, so steep. The first one is more steeper. The second one is less steeper, right? So the steepness of the graph is representing the slope. All right. So if somebody asks you to climb up this, then you would be ready to climb up the graph number two, the straight line number two, because that is less easiest for you. But the first number is a little bit tough for you because that is more steep. So this change in the curvature, the value of y is represented by the, with respect to x, is represented by the slope of the line. I hope you got my point. So that's the meaning of a slope. And that's how we can find out the slope of a straight line, right? Let me just give you one example so that we can learn it, how to use. Suppose I give you one straight line. That's the y-axis, that's an x-axis. Okay. Now let's say I'm giving you one straight line. This coordinate is 1, 2, and this coordinate is 5, 6. What will be the slope of the straight line? So slope is equal to change in y upon change in x. So you see one thing. What is the change in y? Final is 6, initial is 2, divided by x change. So final is 5, initial is 1. 6 minus 2 is 4. 5 minus 4 is 1. Minus 1 is 4. So slope is equal to plus 1. So that is the meaning of a slope of a straight line. Got my point? Okay. Let me show you one more side, one more way to understand the slope, right? So first of all, you have to remember slope is equal to delta y by delta x. Another way to analyze this. Now you are learning the mathematics, so I can show you one more part here. If you remember, I gave you the tan theta formula here. Tan theta is equal to perpendicular, which is B, and base, which is A. So perpendicular upon A is the tan theta. Let us come back here. What is this length? This total length. Can you calculate this length? What will be this length? Try to calculate this. It will be y2 minus y1. Yes or no? It will be y2 minus y1. Okay. And what about this length? It will be x2 minus x1. Yes or no? So basically, like suppose I take another example. Yes. I can show here. Yes. Just a second. Let me make a straight line. That y2 minus y1 and x2 minus x1 thing I'm going to explain you in detail. Wait a second. It's a straight line. Okay. Let us take two coordinates. This is, let's say, x1. This will be x2. Here, let's say this is y1. So this coordinate will be how much, guys? It will be x1 comma y1. What about this one? Let's say this coordinate is y2. So this coordinate would be x2 comma y2. Okay. Now you see one thing. Let us make an horizontal line. Okay. So what is the change in y? Delta y? Delta y is nothing but y2 minus y1. What is delta x? It is x2 minus x1. You can see that x1 to x2 is going. Y value is going from y1 to y2. Okay. You see one thing here. This angle is theta. Let us represent it by angle theta. Can you tell me what will be the length of this line? Total length. It will be y2. Total height. Because that's the coordinate y2. Okay. And what about this one? It is y1 because that's a total length y1. That was a total length y2. So if this is y2, this is y1, then what will be the remaining one? total minus the small one, y2 minus y1, total minus smaller one. Similarly, this is x2, the total length x2. This is the total length x1. So the remaining one would be how much? x2 minus x1. Now you look at this triangle. Let me highlight this with a green color pen. You look at this triangle. It is a right angle triangle. It's a right angle triangle. And tan theta is nothing but perpendicular upon base. Perpendicular is the side which is opposite to the angle theta. So y2 minus y1 upon x2 minus x1 is the base, which is nothing but delta y by delta x. And that is nothing but the slope of a straight line. Always remember this. It's very, very important if you want to grasp in the kinematics chapter, the first chapter of physics, motion in a straight line, motion in a two dimension. Throughout the physics, you will need this. The tan theta is equal to delta y by delta x, or tan theta is also the slope. Okay. So now either I give you the angle theta or I give you the delta y by delta x, you are able to find out the slope. You need to remember the values of tan theta. So it's my suggestion to you that after this lecture, you remember the values of sine, cos, and tan. All right. So here you can add one more thing. The slope is also equal to tan theta. So now you have come up with the grade 9. Do one thing from theta equal to 0 to 90 degree. From 0 to 90 degree. Not saying 1, 2 degree. The standard value 0, 30, 45, 60, 90. For all these angles, you remember the sine, cos, tan values. It would be beneficial for you if you remember them directly. It would be helping for you. All right. So if you remember them, you can easily find out the slope of a straight line. You can easily find out the addition of two vectors because you know there was a cos theta in the square root formula. Okay. Now going ahead with the differentiation. Now differentiation, before coming to differentiation, that's why purposefully I have taken the slope of a straight line. Otherwise I could have come up here, because once you know the slope of a straight line, you can easily remember it. You can easily understand it. What is differentiation? Slope we have discussed for a straight line right now, but slope can be for a curve also. So how do we find out the slope for a curve, right? And what it would represent? Now that is very easy. Do not get confused, right? Let us go very slowly. First of all, let us recall, what do we understand? We understood that slope means how fast the value of y changes as the value of x changes. Do you remember that? Slope means how fast the value of y changes, delta y, with respect to delta x. In a straight line, that delta y by delta x would be coming always same. Anywhere you take. Whether you take the angle theta here, or you take the angle theta here, or you take the angle theta here, it would be always same because everything is parallel to the horizontal axis. So all the angles would be same. This middle angle would be always theta only. Okay. So, but in a curve, that is not possible. That is not necessary. Suppose I take one example for a curve. Okay. So let's take one example for a curve. Right. Let me take the curve here. Just a second. Yes, we can make this side. What differentiation is? Forget about it. We will understand it easily just now. Okay. But what it represents, the slope, the same concept, that same understanding, we are going to use here to understand the differentiations. Okay. So, for example, we are having one curve like this. Okay. Y versus X. It can be velocity versus time. right? Let us take velocity versus time. All right, so that we can understand also. Let us take velocity versus time. So what this graph is representing, as time passes, how velocity is changing. At this value, velocity is this. At this value, velocity is this. Right. So basically, for different values of x, for time, the velocity will be given by, like, suppose at this time the velocity will be here. Suppose at this time the velocity will be here. Suppose at this time the velocity will be here. That number you will get. Now you want to, if somebody asks you the question, it's a very good concept. If somebody asks you the question that how fast the velocity is changing, how fast the velocity is changing. So let us see that. How to figure it out? You know very one thing. I know how to find out a slope of a straight line and how fast y-axis changes with respect to x-axis. Because here on the y-axis we have velocity and on the x-axis we have time now. So how y changes with respect to x? Here I will say how velocity changes with respect to time. You could have taken anything on the y-axis. How momentum changes with respect to time, how position changes with respect to time. So anything you can take on the y-axis. For example, I have taken velocity on the y-axis. Okay. So how velocity will change with respect to time, that I know is given by the slope. Now, if that is given by the slope, so let's try to find out the slope. But we have learned it for a straight line. How to find it out? We know the straight line for the slope for a straight line. So let us take a very small interval. How much small interval? Very small interval. Infinitely small, right? This interval. Though I have taken let me take here very small interval only so that you don't get the wrong assumptions. Very small interval, very small size. Okay, it's a very small size interval. Can we consider this small size interval as a straight line? Yes, we can. We can consider this as a very small interval, as a straight line. It's not a curve now in a very small size. In a small size, it would be almost like a straight line only. Let me show that straight line here. It's like this. And what do we call this? It is called the tangent of a curve. See this, the line which is touching the curve is called the tangent of the curve. It would not intersect the curve at that point. It would be the tangent at that point. Tangent at that point. Okay. So this very small interval you have taken, let me show this here. Now this would be changing from here to here. You got my point? Okay. So basically what I'm saying, just a second. Yeah. Let me redraw it. This was the curve and I had taken a very small interval. Very small interval. So at this place, some value is t, right? And at this place, some other value will be there. Some t plus something, right? So as we know that a bigger change is taken by delta t. This must be some change now. This would be some change only. Like we have taken in the previous case as delta x. Here you see, I have taken this as a delta x. So here I am taking about the very small change. This one, it would be some delta t, right? Okay, but always remember when you talk about the small change, the large change is represented by delta t. The small change will be represented by dt. Small d, small t. Okay. Yes. So this is represented by dt, the small change. So what will be this? It is t plus dt. So this coordinate is t and this coordinate is t plus dt. You take the difference of them, t plus dt minus t. You would be getting dt, which is this length. Similarly, this is, let's say, velocity. So what will be this? This will be some v plus dv, some v plus delta v. So here it is a small. So always remember small change, Small change, small d. Large change, delta. So velocity is changing from v to v plus dv. So what will be this length? This length will be dv. Let us show all these things here. So this was that small section which I was talking about. And here you can see this length is dt and this length is dv. Yes. And now we know what is tan theta and what is slope basically. So slope would be change in v upon change in t, change in y upon change in x. So what we will be writing here for the slope? Slope would be dv by dt. Oh, nice. Slope would be dv by dt. If I would have taken y on the x, y there instead of v, then slope would have become dy upon, and if I would have taken x on the horizontal axis, dx. Got my point? If somebody takes x on the vertical axis, time on the horizontal axis, then dx by dt. Momentum on the y-axis, time on the horizontal axis, then dp upon dt. So in this way, you can find out the different graphs and their slopes you can find out. So at this point, but see, this slope would keep changing at every moment. It's not a straight line now. Somewhere else, if you take the interval, it would be not be that much steeper maybe. Like here, if you see, it is very much steeper. But here, if you see, it's becoming almost horizontal now. Right? So the slope would be different at different points. So yes, the rate of change will be different at different points. Got my point? So basically what I'm saying here now, that when you talk about a graph for a curve, then if you want to find out the slope, what you need to do, you need to take a very small interval. Okay. And that small interval is represented by dv or dy in general, right? And on x-axis, it is dx. So if you are taking time on the x-axis, then dt. You know how to write down the slope. Either you can say perpendicular is dv, base is dt, tan theta, or you can say that it is simply change in y upon change in x. So dv upon dx, या फिर dy upon dx. Okay. Now this dy upon dx, it is representing the slope of a straight line. What it is representing? Slope of, basically it's a slope of the tangent at a point we are discussing, at a very small interval, at a very point, particular precise point. The slope of the curve at a point. Slope of the curve at a point. That is what the meaning of dy by dx. That is what the meaning of dy by dx. Okay. And this is nothing but the differentiation. This is nothing but the differentiation. So it represents the slope of a curve at a point. In a straight line, it would be same everywhere. So you don't need to say at a point. It will be same everywhere. But for a curve, it will be different at different places because the steepness changes. Right? So that's what. Suppose if this is a curve, then you can see the steepness is decreasing. Here it is more steeper. Here it is less steeper. So slope would also decrease. Right? So that's how you can imagine it. So it represents the differentiation is the slope of a tangent of a curve at a point. It represents the change in values of y as x changes for a function y is equal to fx, any function y, right? It can be velocity, it can be force, it can be acceleration, whatever you want, represents the differentiation dy by dx. That's what we have understood. Okay. Now some general results I am going to discuss, and then we'll take one or two questions, and then we'll end this. Okay. So suppose now, first of all, if I talk about the change in y with respect to change in x. All right, just a second. See here. First of all, let me recall delta y by delta x is the large change in y upon large change in x, which we usually use for straight lines. But for a curve, we need to find out the steepness or the slope at a particular small interval. So that is represented by dy by dx. Got my point? Okay. Now differentiation of polynomials. Let us apply this now. A is some constant here. A is some constant. So if you find out the differentiation of a constant, it will not change. A constant number, suppose differentiation of 5, it will be 0 because d5 is 0. Change in 5, it can't be changed. X can be 10, X can be 20, X can be 30, 40, 50, 70, 100. X can be anything, but 5 will remain 5. So no change. Okay. Now, if there is any constant, then you can always take it out, right? Okay. So let us come to this formula first. Then we'll come to the second formula, right? D by dx of x power n is equal to n multiplied x raised to the power n minus 1. All right. So what does this formula represent? Formula represents that suppose you are having d by dx of x power n, right? So let's say, for example, d by dx of x square. Compare it. What is the value of n? N is equal to 2. So put in the formulas. D by dx of x square, it is 2 x power 2 minus 1. All right. 2x power 2 minus 1. Similarly, suppose d by dx of x cube, n value is 3. So 3x power 3 minus 1, which is nothing but 3x square. This is nothing but 2x. Got my point? Suppose d by dx of 2x cube. So this is a constant term. Take it out of the differentiation. So 2d by dx of x cube. And this d by dx of x cube you have done just now, which is 3x square. So 2 multiplied 3x square. That would give you 6x square. So that's how you can write on the differentiations. Got my point? So any constant, you have to take it out. And then you simply do the differentiation of x power n, which is n x power n minus 1. Here also, a d by dx of x. How we'll do this? A d by dx of x. When you take a as the out of the differentiation, so this will become 1, d by dx of 1, because a multiplied 1 into x power 1 minus 1. So a into x power 0, which is 1 only. So a. I hope you have understood this point. So that's the meaning of differentiation. Okay, let us learn now. So basically, suppose if somebody gives you position time graph, this is an extra information which I'm telling you. You will be using this again in the next lecture, right? So in the next chapter, basically, position time graph, if somebody gives you, so what will be the dx by dt? Change in position upon change in time. What do we call it? Velocity. How position changes with respect to time, it gives you velocity. So slope of position time graph gives you velocity. Change in velocity per unit time with respect to time, acceleration, right? And some extra information, change in acceleration with respect to time, it's called jerk function. I don't know for which symbol we represent it, so I'm just writing the jerk. Okay, so you keep deriving it, you keep doing the derivation. Derivative of this, position derivative gives you velocity, velocity derivative gives you acceleration, acceleration derivative gives you jerk. Actually, when you will be going in the higher grades, you will be learning one more trick, which is called the integration. One more mathematics, sorry, right? So when you integrate jerk function, you get acceleration. When you integrate acceleration function, you get velocity, position. So reverse is done by the integration, which is not in our course right now. Right now, our focus is on differentiation only. Got my point? All right. Let us take one example and then we'll go ahead. So differentiation of the polynomial. Suppose this polynomial you have got. Okay. So let us do it here. Y is equal to 20x power minus 4 plus 9. So how to do the differentiation? Dy by dx. So we will write dy dx 20x power minus 4 plus 9, We can write down then separately 20x power minus 4 plus d by dx of 9. Separate you can write down. If we would have a negative sign here, I would have written the negative sign here. Now what is this term, guys? D by dx of 9, constant term, 0. What about this, guys? Take 20 outside, okay? And then x power minus 4, d by dx of x power minus 4. So n x power n minus 1. So n is minus 4, x power n minus 1, minus 4 minus 1, which will give you minus 80 x power minus 5. Just apply the formula, guys. You can do it easily. All right. So that's a way you do the differentiation. Though this today's lecture was very much mathematical, but of course you will remember this lecture when you are going ahead with the Newton's laws of motion, kinematics of motion in one dimension, right? You would be using this entire mathematics. You will be applying there. So Newton has done with the entire calculus, has come up with the entire calculus, this differentiation and all, to understand the velocities, acceleration, and all the such things, right? So basically, when you get the graph of position time, you can find out the slope. The slope would represent the velocity. So you can tell how the velocity is changing if you can tell the slope of the graph. Got my point? So that's all for today. Now we will. Now you will be learning the next chapter, which is the motion in one dimension. There you will be getting the advantage of this lecture only. So always make a short notes of these lectures with you in the class, because this lecture would be helpful and it would be used every time in the physics. All right. So I hope you understood this lecture. And if you have any confusion, if you have any question, put it on the batch discussion forum. So that's all from my side. Thank you so much, guys. Welcome.